learning about converting between amount in moles and number of particles. The particles can be atoms, ions, molecules, or formula units depending on the substance. So we use Avogadro's number, this number 6.022 times 10 to power 23. And here is the real definition, the equivalent of Avogadro's number. 1 mole equals 6.022 times 10 to power 23 particles. So 1 mole of any substance is equal to, or 1 mole of any substance contains 6.022 times 10 to power 23 particles of that substance. That comes from this equivalent, which is actually the definition of Avogadro's number. So Avogadro's number is just like the counting unit. Just like 1 dozen is 12, similarly 1 mole is this number. So this equivalent gives us two fractions. Even though in these fractions numerators and denominators are opposite, they are switched, but they are still giving the same information. They are still the definition of Avogadro's number. In this case, it is just the inverse. Okay, so this 1 mole equals 6.022 times 10 to power 23. It is the real definition, and this definition will help us to go from one unit to another. So the unit that we are given to the unit that we have to find in the problem. Now, which fraction are we going to use for solving our problems? It depends on the problem. What is being asked and what do we have to find? We always go from known to unknown. So our unknown unit, if I have to find moles from particles, I'm going to pick this fraction, moles at the top. If I have to find particles from moles, I have to pick this fraction because this is ending unit at the top. So ending unit at the top and starting unit at the bottom. That is how you figure out which fraction you're going to pick, because that fraction will leave us with the units that we want and cancels out the rest of the unit. Okay. Alright, so here are the steps for unit analysis, dimension analysis. You read the problem carefully, look for the given and what is being asked to find out. So these are the basic steps for dimension analysis. You always go from known to unknown. You multiply the given units with the appropriate fraction. So you're going to pick the fraction. Appropriate fraction is the one that has the desirable or the unit you want at the top in the numerator. And don't forget to cancel the units. That the unit cancellation is part of dimension analysis process. So numerator and denominator, same units, you cancel them. That's the whole idea. And at the end, you should be left with only the units that you wanted, not any other units. That's all should be there. Always look carefully that when you're doing the math part, do you have to multiply or divide? That's very important. Sometimes we get mixed up. Your calculator can give you the answer in scientific notation if you have a scientific calculator. Otherwise, if it doesn't give the scientific notation, just follow the rule of moving decimal to the left, and when you move to the left, you add to the exponent, or moving decimal to the right. When you move the decimal to the right, you subtract from the exponent. Now, what happens is, just remember the rule for scientific notation. You need only one non-zero digit to the left of the decimal. Regarding the rules for significant figures, well, your calculator is not going to give you significant figures. And for these problems, mainly, what you do is the significant figures in your answer should be the same as the significant figures in the given of your problem. Okay? Alright, let's start with this problem. Moles to particles. Now in this case, our particles are atoms. So how many sodium atoms are there in 2.54 moles of sodium? Now we already know by definition that 1 mole of sodium will be equals to 6.022 times 10 to power 23 atoms, right? Atoms of what? Atoms of sodium. So we are going to write here sodium. Let's make this equivalent fraction here. All right. So they're asking you if this many moles is equals to this many particles, then in 2.54 moles, how many particles, how many sodium atoms will be there, right? So you start out with the given, always go from known to unknown. This is my known and this is my unknown. This is the direction, known to unknown. Okay, so 2.54 moles of sodium, and you do it over 1. This 1 will not change anything because it has no unit, but by placing 1 in the denominator, you can tell clearly that you are working with the fractions. All right, no confusion at all. So here, let's set up the problem here. Fraction 2.54 moles of sodium. Now you want to get rid of the moles of sodium. What do you want in your answer? You want atoms. So atoms have to be at the top. So when you make a fraction out of this equivalent, have the atoms at the top and moles at the bottom. 1 mole sodium, you cancel out moles and moles. Atoms of sodium. Okay, use the calculator, multiply, and this is what you should get. Significant figure 1, 2, 3. 1, 2, 3. By 3 times 10 to power 24, because the next number is 9. And atoms of sodium. Okay. So to convert from moles to atoms or moles to particles, you multiply the given moles. Multiply the given moles by Avogadro's number. Now why are you multiplying? Why are you not dividing? That's because by setting this fraction like this cancels out the units that you don't need, and you're left with the unit which you actually need, or which you actually is asked to determine. Now let's look at this one here. Calculate the number of molecules in 4.5 moles of carbon tetrachloride. So again, you got to set up the equivalent here, and also what is given here is this one. This is your moles, right? Your given unit is moles, and you have to go to molecules. So moles to molecules. So first you set up the equivalent. So 1 mole of carbon tetrachloride will have how many molecules? 6.022 times 22 times 10 to power 23 molecules. So in 4.5 moles will be how many molecules? How many molecules will be there in these many moles, right? So let's start. Okay, let's start with given. What is our given here? 4.5 moles. Here you go, and then over 1. Then you pick the fraction where you have molecules at the top, because that is your ending unit, and moles at the bottom. There you go. All right, then next, cancel, and you're going to use your calculator. 2.7099 times 10 to power 24 molecules. Okay, 1, 2, right here for sig fig. That's where you round off. All right. So once again, for sig figs, in these problems, your final answer should reflect the same number. Your final answer should reflect the same number of sig figs as in your given. Now calculate the number of hydrogen atoms in 1 mole of water molecules. So here is an equivalent that we already know by definition. 1 mole of water has these many molecules. Now in the question, they are not asking you how to find the number of, in the question they are asking you to find the number of hydrogen atoms. All right, in 1 mole of water molecules. They're not asking you to find the water molecules, right? They're asking you to find hydrogen atoms. So we are going to need another ratio. So first, for that ratio, let's start it out first. Let's start. Well, 1 mole, these many molecules. Now what is your ending unit? Again, what is given? Given is moles here. And you're going from moles to atoms, which is particles. But so first we are going from moles to molecules and then atoms. So let's start Look at this problem here. I'll write it here. 1 point mole of water, okay, over 1. All right, so I want to get rid of the moles. So I'm going to make the fraction from here in such a way that moles of water at the bottom and molecules at the top. All right, cancel. And here, since they are not asking you for the molecules, they are asking you for the atoms. So we need another ratio. Let's write here H2O. So here, 1 molecule of H2O, right? 1 molecule of H2O. So let's look at the ratio of atoms here. How much hydrogen is here, right? In 1 molecule of water. So that's what you have to in order to tell this ratio, you have to make the ratio from the number of atoms and the whole molecule. So 1 molecule of water is here and it has 2 atoms of hydrogen. So actually how much in 1 molecule of water is contributed by hydrogen atoms, which is 2 atoms. All right. And then you cancel this, the units that you don't need. Use the calculator, multiply. You're going to get this number. Okay. Now, how about if you were asked to find, instead of hydrogen atoms, you were asked to find oxygen atoms in 1 mole? What would you do then? Well, all these steps will remain same. So if you were asked to find oxygen atoms, okay, instead of hydrogen atoms, all this step, same. This would be same. Instead of this, it would be 1 atom of oxygen. That's the only difference. All right. Because for 1 molecule of water, 2 atoms of oxygen and 2 atoms of hydrogen and 1 atom of oxygen. So here is the difference only. So when you will solve this, you're going to get just this answer because there is nothing else. Everything is multiplied and divided by 1. So it would remain same. Atoms of oxygen. Okay guys, these units are very important. Don't forget to write the units because these numbers without units will not make any sense. And measurement consists of both the number and the unit. How about if you were asked to figure out the total number of atoms? Then what would you do? Then you would add this and this. Number of atoms of hydrogen and number of atoms of oxygen. That is how you would tell the total number. So 1.20 times 10 to power 24 plus 6.022 times 10 to power 23. Well, here you have to use the rule of adding with scientific notation. You have to make either this 23 or make this 24, either one. All right. The exponents have to be the same. So if I move this decimal over here, this will become 24. Okay, now you add these numbers, this comes out as common. Atoms, these are the total atoms in 1 mole of water molecule, in 1.00 mole of water molecule. Alright, so here is a very similar problem. In that problem you had water. In the problem that we just did, you had to calculate number of hydrogen atoms in 1 mole of water molecule, and here instead of atoms you have ions. That was water molecule, and here you have sodium carbonate formula unit. That's the only difference. And there you had 1 mole, here you have 3 mole. Rest of the steps are exactly the same. So 1 mole of sodium carbonate would be how many formula units? 1 mole of sodium carbonate would be 6.022 times 10 to power 23 formula units right here. Okay, and then you start your problem with the given. And what is your given here? this one, 3 moles of sodium carbonate. Now in these problems, guys, it's very important to know the formula, the correct formula, because they are asking, talking about ions or atoms, and we need to know the correct number, otherwise this will not be the correct ratio. So here, in 1 formula unit of sodium carbonate, right here, how many ions of sodium are there? You have 2 ions of sodium, right? And that's what the question is asking. The question is asking, calculate the number of sodium ions in 3 moles of sodium carbonate. So you will have an extra step at the end. Okay, and then you solve it and solve it all the way down until the correct significant figures. Now here, particles to moles, a copper wire contains 2.65 copper atoms. How many moles of copper atoms does it contain? So here, this definition, 1 mole of copper equals 6.022 times 10 to the power 23 atoms, that we already know right from the beginning. This definition is telling us that 6.022 times 23 atoms copper are equal to 1 mole of copper. So these number of atoms, these atoms will be equal to how many moles? So what are you doing? You are going from atoms to moles, from known to unknown. So when you make a fraction out of it, you have to make it in such a way that moles are at the top and atoms are at the bottom. Let's start out with given 2.65 times 10 to the power 15 atoms of copper over 1, right? So what do I want to cancel? I want to cancel the atoms. So atoms at the bottom, these many atoms in copper, which are equal to 1 mole of copper. Cancel this and this, and when you divide these, you are going to get moles of copper. All right, be careful about the unit right at the top. So this is correct significant figure. Well, everything is good here. You have correct sig fig, scientific notation, everything good. So when converting from particles to moles, right, or you could say atoms to moles, because in this problem it was atoms. Atoms to moles, we multiply the given atoms by inverse of Avogadro's number. This is inverse, or you could say we multiply, we divide, like, because it was inverse, so, or you could say we divide by Avogadro's number. So you could multiply by inverse, so given, multiply by inverse of Avogadro's number, or divide by Avogadro's number, same thing. Now why would you inverse here the Avogadro's number? Why would you do that? That's because by doing that, you get rid of the units you don't want in your answer, right? That's why you use the way you inversed it. Let's do the other problem here. How many moles of sulfur atoms are there in a sample that contains 2.16 times 10 to the power 21 molecules of sulfur dioxide? So in this question here, you are asked to find the moles of sulfur, all right, not the moles of sulfur dioxide. Again, this is the problem like where you have to use one more ratio, one more conversion factor. So we need one more conversion factor, right? Because first you have to go to molecules, and from then, or first you have to go to moles of sulfur dioxide and then 2 moles of sulfur. So we're going to start out with given, which is 2.16 times 10 to the power 21 molecules sulfur dioxide over 1. Okay, now here let me set it up. So at the bottom, what do I not want? I don't want the molecules. So when you are making a fraction from this equivalent, from this definition, 6.022 times 10 to the power 23. You have to write molecules of sulfur dioxide in 1 mole makes it 1 mole of sulfur dioxide, right? Cancel out this. But we are not going to stop here because they're not asking you to find the moles of sulfur dioxide. In fact, they're asking you to find the moles of sulfur. Sulfur. Okay? Alright, so we need another ratio here. Let's look at SO2. Now look at the subscript. This is one subscript when you don't have any subscript, and this is 2. Subscripts tells you the number of moles. So here let's set up the ratio. In 1 mole of sulfur dioxide, how much is contributed by this sulfur? 1 mole of sulfur. Okay, no subscript means 1. Alright, now you're going to cancel out the units, same units, and top multiply bottom divide. So multiply, so top divided by the bottom. Okay, this is what you should get. Now how about if you were asked to find moles of oxygen? If you were asked to find moles of oxygen instead of moles of sulfur, what would happen then? This step same, everything same except this step. How we have here 1 mole of sulfur, you would be writing 2 moles of oxygen. So that's the only difference. So what's the difference here? They're asking in the question, how much is sulfur contributing here? So this much is the contribution for 1 mole, and here this is the contribution of oxygen in 1 mole of sulfur dioxide, and for each one you have to find how many they are in these many molecules of sulfur dioxide. Okay, now what you're going to do, you can just multiply this by 2, or you can just plug in values and solve it. That will give you the answer, this one. Okay guys, and then if you have to find total moles, for the total you will add this and this. That will give you the total moles. Okay, here you should try these problems, and if you still have trouble, that means you need to go watch, pause, turn on the captions, take notes, just practice more the similar problems. And here I have given you the answers for all of them. So if you don't get those answers, you really need to go back and practice more. I don't encourage students to use the mole map. However, if you want, you can use the mole map. I just ask the students to use unit analysis method because that's really logical. The unit analysis method, it automatically cancels the units that you don't need. Alright, thank you guys. Thank you for watching. I hope the video was helpful.